Hello. Next set of nails will be about let block. So all of you knows what is let block and which purposes was it created for. But let me explain you some interesting points from my point of view. First of all, I'd like to start from from the interesting story which takes place about 5 or more years ago, when I was newbie in Clojure, and one of my colleagues asked me some question about why some block of code is not working correctly, is not working right. I'd look on this block, I saw the let block, and my immediate answer was, as let is macro, then, and blah blah blah. And he stops me. Oh, okay, thanks a lot, I'll macro expand it and will analyze it myself. And he goes to his place and solves the problem in a short time. Then later I remember this story, and that's why. That time I was sure that let was a macro, but I was sure about it in a wrong way. And later in this nail I'll explain you what do I mean. For example, let's analyze what is let in Clojure directly. Let's type let in REPL, and yep, we see can take value of macro Clojure core let. So it's true, definitely. Clojure core let is a macro. But if it's a macro, what can we do with macros? We can macro expand forms which uses a macro. So I have a nice wrapper for macro expanding the forms. And you can see the simple form let a is sign of some variable x, global variable, and return the expression of sum of a and 1 divided by a. So let macro expand it, and we see that it expands in a way as it really is. Let asterisk which is really not a macro but a special form. Let asterisk bins a result of math sign of x, and returns the same expression. So the first question is what actually let does in this situation? And the answer is that in this situation does nothing, and the reason why let is macro is for providing so-called in Clojure destruction forms. For example, if we will eval this form, here we have a destruction as a vector, first and second element. And in expanded form you see let first variable, temporary variable vec dash dash 3757 blah 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 bins a vector, and a bins with first element of vector, and b bins with second element of vector, with nil as default values. So then it makes sense that in Clojure world let is an actual macro which uses for providing destruction. But let me explain what do I mean when I long times ago said my colleague that let is a macro. I have read a book named SIG, Structure and Interpretation of Computer Programs, which I strongly recommend to read all of the Lispers and Clojurists, of course. And then there was a topic, and maybe this nail is inspired by this topic mostly. So what does it mean? Let me start from the beginning. Why do we need so-called local bindings? for providing usability and avoiding duplications in calculations. So let's example that we exactly have to calculate this equation, sum of the sine of x and division of 1 and sine of x. For example, this way. We can do it straightforward, and we have a result. And in such type of languages like C++ and other, which has built-in optimized compiler, and we can hope that compiler can do optimization itself and avoid of duplication of evaluation of this function. If he will sure that this function is a clean function and we can calculate it once without side effects and so on and so forth. But let's not complex things this time. And yes, we can do it this straightforward way, but let's imagine if we have no LED block, if we have no local bindings at all. What should we do? Some of you can stop the stream and trying to guess which way can we provide for it. Yep. And then let's continue. First of all, we can use row lambda in place. Here, as you see, there is a lambda with one argument, and this result returns the exact expression we need, and it's called on actually the argument we need. And here this argument will calculate once. And the same result, yep. And for more complex cases, we can we may want to construct a complex structure based on some input arguments, and these input arguments are hard-weight for calculation and used in resulting structure multiple times. We can create a lambda with any arguments and calculate it. And it's a real case, it's a real way, and it works. It allows us to to not to hope on some mystic optimized compiler and so on and so forth, but set it directly. And though it's there is a first thought about it, that we can abstract it as a macro. So let's create our own navelet, which will expand in such type of forms. And we can do it. This navelet macro. Maybe we will not describe it in details, but it does the same thing. Let's macro expand this expression, for example. Yep. Let a math sine x and plus a divide 1 by a, and it expands in the same thing. Function lambda in place lambda of one argument and blah blah blah. The same thing as we have here. And the second thing, we can have multiple bindings inside of LED block, and it also expand in a desirable way. So function of two arguments and so on and so forth. But what is the limitations of such type of navelet? The limitations are that all these bindings inside the LED block should be should not rely on each other, should be independent. For example, if we may try to do this way, let a is math sine x, but b is increment of a. Yes, it really expands, and it expands a function of two arguments, but the call of this function will be on sine x, which is valid expression, and inc a, and a it's not binded in a in our surround. So if we will call the expressions directly, the value, the real value, and here syntax error and so on and so forth. Actually, scheme language has two LED macroses, and one of them implemented actually this way. It utilizes construction in place lambda, and scheme language doesn't have let as core special form at all. So if we have a lambda, looks like we do not have to have core special form called let, and all the local bindings we can make and abstract with lambdas. So that's up for this nail. See you in the next nail, where we will improve our naive let macro. See you.